Very briefly, to introduce our team at Ghent University. We're part of the central IT department, so we cater to the whole university, not to a particular research group or research domain. We are fairly young, especially on the European scale, if you compare us to Zurich or the people in France or the UK, for example. So the team was only established in 2008. Our first cluster was installed in 2009, so we're still learning a lot, let's say. And we're also a member of the Flemish Supercomputer Center, which is a virtual collaboration between the Flemish institutions. It's virtual in the sense that there's no physical center, and sometimes it's also a little bit virtual in collaboration. That's getting gradually better. So the infrastructure we have is actually quite a lot, especially since we've only been around for about 5 years. So we have 7 Tier 2 systems. So I'm not sure if everybody's familiar with the tiering system that's being used in Europe. So Tier 2 systems are kind of like bottom layer, so it's a pyramid system. They are, let's say, currently about 1,000, maybe 2,000 cores systems, either with or without the high-performance InfiniBand network. It depends. But they typically are local to a particular institution, so they are, let's say, affordable for one institution to pay for the hardware, the power, support, and so on. So we have 7 of those, which is already quite a lot. We also have one Tier 1 system, which is like a factor bigger and more expensive, which is operated by the Flemish Supercomputer Center, so it's shared by all the Flemish universities. And that system is about 8,500 cores, 150 teraflops. So for us, it's quite big. And we came in the top 500 at rank 119, which we were very happy with. We're still there right now, but we're gradually dropping. I don't think we'll be there for a year. We get kicked out pretty fast. But it just gives an idea of how big the system is, especially for a small site like us. Our team is 8 full-time equivalents, which is not that much because we have, I think, about 1,200 servers, physical servers, spread over 8 clusters. So it's quite a lot of work. I think we have about 500 active users in several degrees of being active. And especially for the Tier 2 systems, we do everything. So we do the purchase of the hardware, we configure the system, make sure it runs okay and has good performance, and then we do the user support. And also for Tier 1, so the Tier 1 system is installed on our location. It's owned by the university. The operations is done on a higher level, on the Flemish level. But the hardware setup and configuration is done together with HP, which is not always a gift. And we also take care of all the user support. So it's quite a big additional task for the team. And up until recently, we were doing that with the same team as we were doing the Tier 2 system, so it was just an extra load. So quite a lot of work. So we do the system administration, user support, user training, and actually EasyBuild just grew out of the need for the user support because we cater to the whole university. We deal with all kinds of scientific software, chemistry, biology, you name it, we probably have it. And we also do quite a lot of effort to convince research groups to switch to the central infrastructure. So we really want to see people, instead of buying a new cluster for their local research department, basically just either switch to the central infrastructure or even better, give us money and switch to the central infrastructure. So we can buy equipment for them and just maintain it, support it. And all they do is log in and use it, which is a lot better for them. And it's a lot better for the university because the clusters are installed in a decent data center with decent cooling, decent power, and so on. So, out of the user support, we quickly noticed that building all the scientific software is lots of fun. So the guy who started EasyBuild back in 2009, he was actually the only technical guy back then in the team. So they were, for quite a while there were only 2 people in the team, 1 manager and 1 technical guy, and he had to run 3 clusters. So it was still getting started, so it was all the time new people were rolling in with new software packages that he had to install, and he quickly realized that this was going to be a huge mess. Just building scientific software is an adventure by itself, because the researchers who write the software only care about what the software does, so the science behind it, and it works for them, and then they just push it out and hope that people will pick it up. But they don't really put a lot of effort in making sure it's usable by others or usable on other systems than their own and so on. So there are all kinds of problems that pop up. I don't think I really have to convince you of this. So the build procedure is incomplete. Sometimes it requires human interaction, so you have a script that asks you questions. You want to use GCC or Intel and so on. Where do you want to install it? So it's really interactive, and sysadmins don't like that. You just want to push the button and have it installed. A lot of it is very customized as well, as Bernd already mentioned. So some packages have a different way of configuring than just the auto tool setup. Some stuff has hard-coded paths or hard-coded compiler commands and so on. And usually, but I think that's common for all software, actually including EasyBuild, the documentation tends to be a bit poor. So you have to figure things out over and over again. So it's very time-consuming for user support teams, and HPC teams all across the world have to deal with the same problems over and over again. So there are some tools out there up to a certain level. So Unite is definitely one of them, and I think definitely one of the better ones. So it at least does it in a fairly decent way. It's specific to performance tools, but that's okay. You don't want to solve all the world's problems. So the first thing to mention is in an HPC environment, you really want to build from source. It gives you the best guarantee of getting decent performance, of linking with the right libraries, using the right compiler that's really suited to your system, and so on. It gives you the ability to use the right instructions for your system architecture, whatever. That's also part of the reason why there's not a lot of packages, so RPMs or Debian files or whatever your Linux distribution is using. There are not a lot of packages available for scientific software because it's a huge effort. It also usually doesn't make a lot of sense because most people just build from source. And it's a huge effort because all the scientific software is very quirky and only a handful of people are using it. So the return you get is very low. There are some build tools out there. Most of them are custom to software packages like Unite. Some are OS dependent, so on Mac you have Mac ports and Homebrew and whatnot. Those tend not to include a lot of scientific software either, for the same reasons. Most of these tools are hard to maintain, so especially Stain, who started the EasyBuild project, hates maintaining bash scripts because it gets really messy quite fast. I don't know if you agree with that. So it's scripting, it's not a proper programming language, so you have to deal with stuff in certain ways.
Each programmer can program languages, like any language.
Sure. Actually, I have a question still here. QTOP to monitor the state of the cluster started as a one-liner. It was a one-liner just to see the states of nodes. And before I knew it, in 2 years, it became a 400 unmaintainable one-cell script full of one-liners, and I don't want to look at it even. I just would like to rewrite it completely in Python or something. So yes, we must do it. Yeah.
I think it probably depends on the guy who's doing it, but Stain really dislikes bash scripts and maintaining them, especially when you get it. And a tool like EasyBuild can get big pretty fast, and that will show up in the next presentation. So the build tool he was looking for actually, he was looking for something that has all these characteristics. So it should be a flexible framework, because scientific software comes up with all kinds of weird ways to install it and build it. It has to be very flexible, so it has to be able to deal with whatever comes up next. It should really allow you to reproduce builds quickly and easily. So if you build it once, you should be able to do it again. For example, on a new system or after an update of the operating system or whatever. Of course, you should be able to have multiple versions and builds next to each other, because that's very common in the HPC world. One thing I'm not sure if this was the idea initially, but it certainly is now. So it should allow to easily share stuff across teams and across sites to avoid that people redo the same work over and over again, and basically to help out each other. So this basically allowed to have one person solve the problem once for a particular software package or a particular system, and then everybody else can build on that effort. The build should be fully automatic, even if they require interaction and patching and whatever goes on. And you should be able to build the whole software stack at once, so it should have some way of dependency resolution. So you don't have to put in all the bits and pieces yourself. The system should do it for you. So he was looking for something that solves these issues. Initially, he was looking at RPMs and writing spec files for scientific software. And after a couple of weeks, he realized, okay, this is never going to work out. Scientific software is so messy, and RPMs are not at all ready for this. So he just started something from the ground up, which became EasyBuild. So he chose Python as a language to write it in because it's very flexible, it's very dynamic, and and at that point he wasn't that familiar with it, and you can see that in the first versions of EasyBuild that are released. But he figured it was a good idea to write it in Python. The development of EasyBuild was done in our team for 2.5 years before we pushed it out. At some point we realized, okay, lots of other people can probably benefit from this, or we can get feedback from other sites, because maybe we were doing it totally wrong, we have no good view on that. Or maybe something is out there that we should be using instead of building this from the ground up. So we started pushing it to the outside world. We open sourced it in April 2012, which is version 0.5, which is the one that Fotis picked up. And then, actually during supercomputing in 2012, we released the first, what we consider to be a stable version. So we cleaned things up, reorganized stuff a bit. So we had a stable API and something we could stick to for a long time. And then since, let's say, January of this year, we've been doing monthly releases. So whatever is there and is stable, we just put it together in a release and we push it out. It's built on continuously, so people are still asking us to install new software packages, so we have support for it. We also try to make it a little bit more flexible, so other people can pick it up more easily and so on. So the things EasyBuild needs, it's a little bit more than what Unite needs, rather. So it needs a Linux system, so it shouldn't be too big of an issue for HPC systems. It kind of works on OS X because I usually work on it on my laptop, but it has some issues that we're probably not going to look into because the focus is really on Linux. It has no Windows support, and we're not planning on working on that. It might sound silly because there's almost no HPC system out there that uses Windows, but some people at supercomputing last year were saying it would make a lot of sense to have Windows support because the first time people try software is usually on their own laptop. So if they have an easy way of installing it there, that would be really useful for them.
Also, EasyBuild is not only for HPC systems. I mean, we build several workstations for people's, small systems, like single machine systems, with EasyBuild because it provides a lot of the tools.
Actually, I think the real issue here is not about having the generality of the tool to support also Windows. Eventually, it will be nice to support whatever. But the real issue here is I think that the Windows users are not so much in the culture of exchanging their experience, so it's actually poor investment of time.
Yeah, I'm not talking about Windows now, but just for it doesn't have to be a big system. It can be, it doesn't have to be a big system to run.
So I think
if you want it.
Yes.
Yeah, but for now it's definitely not working out.
Yeah.
So yes, we need Linux or some version of Unix, let's say, to make it a bit more general. It does need Python. That's a really strict requirement, of course. We still stick to an old version of Python, so Python 2.4, which is quite old. The reason for that is because on Scientific Linux 5, Python 2.4 is the standard version on the system, and upgrading that on the system is an utter nightmare, so nobody does that for very good reasons. And up until now, it's not too big of an issue. You're missing some features of the language, but nothing really big that you need that to clean up the whole code base. So it's still quite okay. And we make sure it works with Python 2.6, 2.7. That's not an issue. There's no Python 3 support yet, and that's actually getting a little bit of an issue because new Linux distributions are shipping Python 3 as a standard Python.
And it's not backward compatible. Like Python 3 can run
Yeah,
Python
you can
3.
actually write a code that works with both versions. So if you just clean it up and like print statements, do them a little bit differently, stuff like that, you can make sure it works with both 2.4 and 3. So that's not a big of an issue, but it's an effort. And then we also need A modules too, so usually that's in hybrid modules. And quite recently you can also use Talmud together with EasyBuild, so that's sufficient as well. And then usually you need, if you want to build your own compiler tool chain, you build our own version of GCC and start from there. But to build GCC you need a system compiler, or you need a compiler available, so usually you need the system compiler as well, so you can get GCC booted and so on. If you're doing it the way Julie is doing it, you just create a wrapper around whatever is there, and that will work as well. So that's not really a strict requirement. So the dependencies are a little bit more strict than Unity, so Python and environment modules. Actually, environment modules is also required for Unity.
Yeah. And then we need our CMake or our thing, so it's roughly the same.
It's not that strict enough. So this doesn't really pose an issue for Unity. What does pose an issue for new people is installing EasyBuild. And the main reason for that is because packaging Python software is an utter mess. So I don't know how many people have played around with that, but there are like 3-4 tools for Python software, for installing Python software out there. And they realize they really have a big issue, and they try and solve it. They create a new tool for it, and they make things worse. So they just add another tool onto the stack, and people don't know what to use.
This is why I don't like Python.
Good point. So that's actually an issue we know about. So people run into problems like you used to specify in the documentation, just use the easy install tool, which is probably available if Python is available on the system, and if not, it's easy to install. So easy install is not something specific to EasyBuild, it's a Python install tool. And just use --user and it will install it in your home directory and you're good to go. If you're not sure how to do it, just try this, it will probably work. It does work, but only if your easy install is new enough, because --user is a new option. So for some people this breaks and they get confused. So they talk to someone who knows Python, and the guy says, you're still using easy install? No, use pip, this is a lot better. They don't have pip on the system, they don't have admin rights, and they get even more frustrated. And then they go back to easy install with --prefix, which has been there for a long time, so it should work. You just let it know where to install it. Make sure you set the path correctly. You try to run EasyBuild, and then it breaks because Python path was not set correctly, and okay, you give up. So this is very frustrating for people that are new at EasyBuild. And the way we try and solve that is by doing a bootstrap. So we have a way of supporting, of installing EasyBuild by bootstrapping it. So just making EasyBuild install itself. And that just boils down to 2 commands. So you get the bootstrap script from our Git repository or the Git website. And then you just run it with Python. You just run Python, the bootstrap script, and then an install location. And what it does, it will first install the easy install tool itself in a temporary location, so it knows which version of easy install it's using and which options it has and can use. Then it installs EasyBuild with easy install to a temporary location, and then it uses the temporary installation of EasyBuild to install EasyBuild and get a module. So the end result of this is, if the bootstrap is successful, and it hopefully is, you can just update your module path, if you installed it in a location that was not in the module path yet. And then you just use modulo EasyBuild and you can go from there. It's really not possible to make it easier like this. So you just make the thing install itself and you get a module out of it, which you are going to use anyway because EasyBuild works with modules. So that should work out. If it doesn't work out, like Bert mentioned, because of the technical modules that are being used at Julie,
It would be another hour to fix this.
yeah, it's not too hard to fix it, but we want to know about it so other people can pick it up as well. If you try this, it should just work, and if it doesn't work, we should know about it. So we kind of consider the installation issue of EasyBuild solved like this, and you can still install it with Easy Install or pip or whatever you want to do. Doesn't really matter. Then the configuration of EasyBuild. So by default, EasyBuild will install the software to in your home directory in .local EasyBuild. The software will go into a software subdirectory. The module files will go into a module subdirectory, and then categorized as well. So all the module files will be in the /all. But it's very easy to instruct EasyBuild to do something else in 3 different ways even. So you can put a configuration file at some standard location, or you can tell EasyBuild to use a particular configuration file. You can use environment variables, so EasyBuild _ whatever, or you can do it on the command line. And the nice thing is it's very consistent, so if you use eb-help, it will show you all the command line options it has. If you want to figure out the environment variable, you just capitalize it and put EasyBuild _ in front. And if you want to do it in a configuration file, the name of the variable you need to set will be install path in the same way as it's specified in the command line. So no dash in between, small letters, and so on. So it's very consistent, and there's no way we can break that. The way we add an option, we add it in one place and it gets activated in all the other places. So, there is a wiki page on configuration, but it needs work. I was actually working on that yesterday during the flight and while waiting in the airport. It's still documenting the old way of configuring EasyBuild, which is an issue. It works, but the new way is a lot better, and in some future release we will break the old way, so people should use the new style configuration. But we'll hopefully get that fixed release. If you follow this, you're doing the new style, so then you should do it. And most aspects of EasyBuild, what it does by default, can be changed in this way. So once you have EasyBuild installed and configured the way you want it to behave, install in a particular location, and so on, we have this quick demo thing to show you how, let's say, powerful EasyBuild is and how easy it is to install software stacks. So if you use the eb command with this easyconfig file for HPL, which is the benchmark that is used for ranking the top 500 systems, and you add the -- robot option to activate the dependency resolution, it will build a whole software stack for you, hopefully successfully. So the first thing we'll do, it will try and download all the sources it needs, so for HPL and also for the compiler toolchain. And then it will build this Golf compiler toolchain that includes GCC, OpenAPI, Atlas, LAPACK, FFTW, ScalaPack, and Blocks. So it will build all of these first, construct a toolchain with that, and then build HPL with this toolchain. So it builds 8 or 9 software packages with a single command, and hopefully without problems on your system. And by default, it doesn't do the default location, but if you set environment variables or add more command line options, you can tweak this one. It's intended as a quick demo. It's actually not that quick because building GCC from source takes about 1 hour, even on the recent system. Building Atlas might take a couple of hours actually. It's a really weird package in the build procedure, so it does some auto-tuning, and depending on how old or new your software is, your system is, it might have to do the auto-tuning from scratch, and then it might run for 10 hours. So it's a quick demo in the sense that you only have to execute one command, but it might take a while. So we're actually hoping to get a better quick demo available, and maybe So that's one of the things I've outlined for this hackathon that maybe people can work. Then some terminology that we use. So we have the EasyBuild framework, which is the core of EasyBuild, all the modules that offer the supporting functionality, let's say. I'll detail that more in a bit. And from the ground up, the framework is very modular and dynamic, so it has all kinds of locations where you can plug in other stuff that are specific to your site or that are new. So if you want to work on pickle modules, you just put a Python module in a particular location, and EasyBuild will, if it's there, EasyBuild will find it and pick it up if it needs to. Same for software support, same for compiler tool change. You can either just use it on the side, that's because it's specific to your system, and you don't want to share it with people, or just because it's not there yet and you're developing stuff. So it's very flexible. Then we have easy blocks, which are just Python modules that implement a particular build procedure, like for installing Scala or installing Go or whatever. It can be specific to one software package, just because it's totally non-standard, or it can be a generic easy block, like for anything that uses configure, make, install. So that's a single easy block, and you can make EasyBuild use that as well. So that's Python code that implements the build procedure. And then we have easy config files, so the .pb files that are a build specification, so which software you want to build, which version, which compiler toolchain you want to use, which build options like configure options or make options you want to set, and so on. So these are actually simple text files. Currently they are still Python syntax, so they are actually executed as Python code. But we want to step away from that for all kinds of reasons. One is security. Another one is maintainability, but I'll detail more on that one. So these are the three terms you'll be hearing a lot about when talking about EasyBuild. So the framework, the easy blocks, and easy config files. So if we look at the EasyBuild design from a high level, we have the framework Python package right at the core of EasyBuild. There you have the abstract implementation of the build procedure, so a easy block, which is with an abstract class. You have the whole package that deals with parsing easy config files. And you have extensions as well, but I'll explain that later. And then you have the tools package, which has a whole bunch of Python modules that support and that offer supporting functionality. You have the tool change package, which is kind of separate for that, so it specifies how to use a particular compiler, how to use a particular API library, and so on. And this is one of the parts that you can just plug and use stuff, and it will use it. The Easy Blocks package is kind of on the side. So here all the Python modules that implement build procedures are hosted, either in the generic sub-package or just directly in the Easy Blocks package. If you look into these a little bit deeper, so the framework again is the core of EasyBuild. It hosts the abstract class EasyBlock. So this doesn't implement any build procedure, but it gives you all the functions you need to implement to make it really work for some software package. And the easy config class, or actually now it's already a package, is for the parsing of easy config files. And then the extension class, which is kind of on the side to an easy block, is something to build and install Python packages together with a Python installation, or our libraries, Perl modules. These are like libraries that are added onto an existing software installation. So you have this for Python, R, Perl, probably other like MATLAB and Octave, stuff like this as well. These are just extensions to a particular software installation. The tools package offers all the supporting functionality, for example, for running shell commands, running make, running a configure script, and so on is done with the run command function. We have a run command QA function as well for interactive commands, so that needs a bit more information to automate these interactive commands. Then we have functions for extracting packages, for applying patches, and for a whole bunch of other stuff. For interacting with the modules tool as well, and so on. Then tools.toolchain package offers the support for compiler toolchains, the generic support, so not tied to a particular compiler or a particular API library. And that will tie in with the toolchains package. I'll show on the next slide. And then fairly recently we also have the module naming scheme package for dealing with custom module naming schemes. So whatever your site has, maybe it doesn't have a policy, maybe it does have a policy for naming modules, we can actually implement it in EasyBuild and make EasyBuild produce the modules like we want. So the toolchains package, this is a little bit confusing. Toolchains package, which is the bottom part of the figure, hosts all the Python classes that implement support for a particular compiler or a particular API library, and that talks to the tools.toolchain package, which is the generic support for a compiler, a API library, and so on. So again, the stuff on the top just basically defines a skeleton that you have to fill in to be able to use a particular compiler for a particular library. It's organized in sub-package to keep it a bit clean. And also this is very modular if you want to use PGI, so you don't have support for PGI yet. It just boils down to writing a single Python module, filling in the commands that are specific to PGI, maybe compiler options that are a little bit different from GCC and Intel. And then EasyBuild can just build software with PGI, or at least try to build software with PGI. Same for API libraries. And this is the location you would plug in, for example, a system compiler class that just figures out what the system compiler commands are, and then just use that instead of one that we install. So that would be one way, and we can look into that. And the module naming scheme package is for supporting custom module naming schemes. This is well documented on the wiki because it's quite new, so we made sure it's properly documented. And the thing you have to do here is you have to make your implementation of the module naming scheme class, which is basically just a single function that takes a parsed easyconfig file, so it has a name, the name of the software, the version of the software, the compiler used, and so on. And based on that, it spits out the string that is the module name. So, because it's a Python function, whatever module naming scheme you have, it can produce it. You have all the information you need to produce the module. It's available since EasyBuild 1.8, so which is the latest major release. But right now it still has it's kind of limited because it only offers to the module, the function that generates the module name. It only offers the software name, software version, the version suffix, and the toolchain. So the compiler and the compiler version, and API and so on that you're using. All the other easyconfig parameters, like the list of patch files and the list of config options that are specified, are not available yet. There's a technical reason for that, but we hope to fix that soon. But we think for now this is sufficient to play back with this. That discusses the whole framework of EasyBuild, and just to give you an idea how complex it is, this is how all the Python modules in the framework are linked to each other. So the green stuff is the tools package, the yellow stuff is the toolchain support, and the really core, so the EasyBlock, EasyConfig extension classes and the framework with a little bit stuff on the side. So it gets big pretty quickly. And this grew over about 5 years, and we're always adding to it more and more to make it easier for other HPC teams to do their thing the way they want it. So it all keeps growing. And then also in the framework we have the test package for unit testing. I'll show you a little bit more on that later. Some scripts that we sometimes use, like to generate the list of supported software on the wiki page, and we just kick it all into the repository as well. There's the main Python script and the wrapper. So the wrapper is actually a small bash script. It's the only bash script in EasyBuild. And it just calls the main script, but in a somewhat fancy way to make sure it works, or to try and make sure it works. And then also the default EasyBuild configuration file, which is still the old style config, so we hope to fix that soon. And then the EasyBlocks package is kind of on the side. It's also in a separate Git repository. So these are all the implementations of build procedures that in the end they all subclass from the abstract EasyBuild class that you can see on the right. So the white blob is the abstract class, and all the blue ones are either generic easy blocks for a particular group of applications, like anything that you just configure, make, install, or for a particular application because it's totally non-standard, for example, the Wharf easy block that I'll be showing you a little bit later. So it's basically a hierarchy of easy blocks, so you can build on the stuff that's implemented in other easy blocks, and it's just object oriented, and it's a way of avoiding code duplication. So you just share stuff across easy blocks as well. Again, very dynamic. If you add your own easy block in the Python search path, if EasyBuild needs it, it will find it there and use it. So it doesn't have to be part of the EasyBuild installation. This is the install procedure that is implemented by EasyBuild. It's possible a couple of steps are missing here, but it gives a good overview. So this is the way it's implemented by the EasyBlock class, and let's say a chunk of this has to be implemented for a particular software package. So some of these steps are generic, some of these are really specific to what you are building and installing. It will start by reading and parsing the config file. It will figure out where the source files are available or try and download them. Then it will unpack the sources. If there are any patch files, it will apply the patches to this impact source. Then it makes sure everything is ready to build, so all the directories are created and so on. It will configure the build, so either run a configure script or do it in some other way. Build the software. If there are unit tests available for the software and EasyBuild knows about them, it will run them. If that succeeds, it will install the software, maybe add extensions like Perl modules or R packages if they are listed. Then it will run a sanity check. I'll detail on that next. If the sanity check succeeds, it cleans everything up, so make sure the build directory is not left behind. And so on. It cleans up hopefully neatly after itself. Then it generates the environment module for the software. And if any test cases are specified, like input files that you want to make sure that work, EasyBuild will run them in the same way as a user would use the software. So EasyBuild will load the module and then just run a test case as it is specified. And if that works, you have a pretty good guarantee that the module works by itself, so all the commands and libraries are available, and that the test case works. So you can, the validation of the test case, that's up to yourself how you implement that. So for some software packages, we are already doing that, and we should actually do that more and more. The sanity check that is done here is something we added very quickly because we noticed it's quite common for software packages, so for the build procedure to fail, but for it to exit with code 0 and just say everything is fine, it's installed, but in the end nothing is there. We've seen that a lot with the Intel tools. They crash for whatever reason. Even if the license server is not there, it just says exit 0, I'm done, but nothing gets installed, of course. We've seen that for other software packages as well. So what we do there, we enforce that people specify a list of files or a list of directories that should be there if the installation works, and EasyBuild to make sure that everything is there. If one of these is not there, it will complain and assume the installation is good. So the check, of course, depends on how good the paths and directories are that you give it, but it's at least a good way. And you can also run commands like if you're installing Scala, you can run Scala as help. If that doesn't work, then EasyBuild can assume something. And it has turned out to be really useful if you don't have always hacking around the checks. So some of the key features, let's say, is EasyBuild, just like Unite, really logs the build process thoroughly and installs it along with the software installation to make sure you can get back to it later. Maybe the installation seemed to work even with test cases and so on, but only when you really use the software in production, you notice stuff is wrong or it's too slow and so on. So then it's useful to be able to look how the installation was performed and see if there are any issues you can find there. The EasyConfig file that is used for the build specification is put into an archive that can be just a directory or a repository, and it's also installed in the installation directory, so you're sure which EasyConfig file was used for this particular installation. Dependency resolution is done with the robot. I already mentioned that. Interactive installers can be run autonomously with the run command QA function. Basically, what you do there is you just give a Python dictionary to the function, and the dictionary maps questions to answers. It just gives EasyBuild a list of questions that it can match, and if it matches one of these questions, it will know what the answer is. And I will show that when I explain the Wharf EasyBuild. We have support for building software in parallel. Right now, it only works with the Torque PBS software, but you can use ed-job, and EasyBuild will just submit the build as a job, and it can even submit a list of jobs for the software stack, and make sure that the builds run in the correct order. So that's something very useful. And when we run the EasyBuild regression test, it's basically a single command. We just do ed everything robot-job, and it fills up the cluster with a whole bunch of jobs, and everything is run in the correct order. If that works out, we're pretty sure that
You have to build KBS Python using EasyBuild.
you have to.
We would like to be able to build KBS Python using EasyBuild.
Okay. Yeah.
Not wasn't really well.
And yeah, PBS Python is
Yeah.
an issue.
Especially with latest versions.
Yeah. But yeah, we can. And so we also do very comprehensive testing of EasyBuild. So we have unit tests that are run every time a change is made. And then we do regression testing as well, which is rebuilding everything we support. Up until now, we're able to do that because all the builds we ship work on our systems. Except for the CUDA builds, for that we have to use the NVIDIA cluster we have access to. If we start adding support for stuff in Julie, we would have to test there, and so on. So this is going to become an issue, but for now it's okay. So unit tests are run whenever a change is pushed to our repositories. So the Jenkins system we have set up is taking care of that. And then the regression tests, those are started manually, and once they are done, we ask Jenkins to put in the result. The regression tests are on the right-hand side. It's just building everything we have, and it's been growing quite quickly. And then the unit tests, those don't grow that much, but those have turned out really useful to catch stupid mistakes and changes and so on, to make sure stuff doesn't break. And you can, it's a publicly available server, so you can see how EasyBuild is doing and when the latest test was run and so on. The list of software we support, this is the updated list. Right now we have 338 different software packages. So some of them are dependencies for other software packages, like libraries, and compilers, API, math libraries, and so on. For these 300 plus software packages, we have over 1700 EasyConfig files with different ways of building the software, maybe with a different compiler, toolchain, maybe with a different build option, and so on. And the packages that are highlighted here in bold are the nasty ones. So the ones we've noticed that are really non-standard or have lots of issues when you try to build them. I'm not sure, maybe some of you are familiar with OpenFOAM. NWChem is a known one. I see Bert is laughing.
I heard some comments about OpenFOAM.
Yeah. Wharf is a weather modeling software. I'll show more details on that later. It's really nasty as well. They have no clue what they are doing to deal with it anyway. And then EasyBuild is in there as well, because it turned out that building EasyBuild with EasyBuild is quite tricky. It does the sanity check and it makes sure EasyBuild is there, but since you're using EasyBuild, of course it's there, you have to dance around it.
The complexity of that is about testing it correctly, testing the correctly, the thing that you install. Dolphin is also pretty spectacular because of the dependency graph it has. It's unbelievable. It's We're talking about 40 different pieces that
Yeah.
are put together.
Without the compiler and the API piece, without the compiler tool chain, I think Dolphin has about 30 dependencies. And most of them are not configured natively installed. So I have no clue how people are able to build that manually on their own. Probably spend a whole week or something, but it's an utter nightmare.
They spend the whole week the second time.
Yes, the first time in EasyBuild. So Jens, who added support for Dolphin, spent like 3 weeks on a single user ticket because the guy wanted to use it. And the 3 weeks were spent by pushing it into EasyBuild, and now reinstalling it is a breeze.
We thank you.
Yes. Are you using Dolphin or?
No, but to be me too, we thank you.
So if you want to know more, the website, the GitHub repositories, EasyBuild is also released via PyPy, so if you use easy install, that's where it actually fetches it from. You have the mailing list that you should be subscribed to if you're really interested. A Twitter feed and an IRC channel. IRC sounds a bit 90s, but it's actually used a lot still. So lots of discussion is going on there. People are popping in every now and then. I have an issue, and they usually get a reply really quickly. And it's faster than email to get help. So it's really useful.